Hello guys, my name is Evelyn and I'm going to be explaining the function of a nephron. Starting off with the anatomy of the kidney, we have the renal cortex here, which is the outer layer. We have the renal medulla, which is the inner region. We have the renal pyramids, which are in here. They're triangular structures. The renal pelvis, which drains the urine, funnels into and becomes the ureter. Starting off with the nephron, there's 1 million nephrons per kidney. Their function is it filters blood to create urine. Each nephron is made of renal corpuscle and renal tubule. So there's about 150 liters to 180 liters of filtration happening, but the body only filters 1 liter to 2 liters of waste. And right here we have the two types of nephrons. To the left is a JMN nephron, which is about 20%. The loops extend deep down into the medulla. They maintain proper sodium levels and water balance in the body. And then to the right, we have the cortical nephron. They have short nephron loops. They produce majority of your urine. They're located mostly in the renal cortex, and that's about 80%. Now we're looking at the nephron, starting with the renal corpuscle, the glomerulus here, which is like a spaghetti straightener, and the Bowman's capsule right here, which is like the sink. So glomerulus is a cluster of capillaries that receive blood from the afferent atrial right here. And this is where filtration occurs. Water, ions, glucose, and small molecules are pushed out of blood and into the Bowman's capsule. Yeah. So now in the Bowman's capsule, it collects this filtered fluid, now called filtrate, and directs it into the tubule system. The function is blood filtration. And then now going to the PCT here. That is where the first section of the renal tubule starts. Majority of reabsorption happens. Water, sodium, glucose, amino acids, substances transported back into the blood. The function is for bulk reabsorption of nutrients, ions, and water. Now going to the loop of Henle, the descending limb is permeable to water only. Water leaves the tubule by osmosis, making the filtrate more concentrated. Going on to the ascending limb here, it's impermeable to water. It actively reabsorbs sodium and chloride, dilutes the filtrate. The function is it creates a concentration gradient in the medulla. Now going on to the DCT here. The DCT regulates electrolyte balance. It reabsorbs sodium and calcium, secretes potassium and hydrogen ions, and here it's influenced by hormones aldosterone and ANP. The volume duct determines the final concentration. The volume of urine, the urine flows to the renal pelvis and eventually exits the body. For hormone effects, urine aldosterone causes the urine volume to decrease, sodium and water reabsorption increase. ADH causes the urine volume to decrease and the urine concentration to increase. ANP causes the urine volume to increase, sodium and water reabsorption decrease. From the 3 hormones that act on the DCT and the collecting duct is aldosterone, which release from the adrenal cortex. It causes a high sodium reabsorption and an increase in potassium secretion. The water follows sodium back into the blood. The urine volume decreases and the blood volume increases, and so does the blood pressure. The AMP also acts on the DCT and the collecting duct, and it's released from the heart when blood volume is high. Sodium and water have a high excretion, more urine, less, and it's less concentrated. It also has a low blood volume, and low blood pressure. The ADH hormone is released from the posterior pituitary. This acts mainly on the collecting duct. More water is absorbed. It's less urine, but it's more concentrated. The ATP pumps ions out and creates a cloud, and then your bladder fills, and then you urinate. Thanks for listening.